Picture the house from Home Alone. Tall, good doors, and with a surprising number of defensive traps inside. One quick move by a crafty 8-year-old, and any unsuspecting bad guys like Harry here get a flaming new haircut. Now, picture this scenario if our bad guys knew the traps were there and came prepared. What if they could unlock the doors, cut the wires, and get out through the back door without Kevin ever even raising the alarm? This is the situation we face with enteric pathogens like Salmonella. Our innate immune system means that our cells are well defended against any ordinary invaders, but these bacterial bad guys have an entire thieves' kit of tools, which they bring into any cell they infect. With these tools, they can disable the innate immune system, modify our cell pathways, steal our resources, and then escape into the surrounding area. And unfortunately for us, the damage they do during this invasion and escape can make us really sick. And this can be particularly harmful in people with already compromised immune systems. In people with no traps in their figurative houses, the bad guys can wreak havoc, spreading wildly from cell to cell, damaging our tissues and sending these people to hospital. Thankfully, we have science on our side. By studying these bacterial thieves tools and learning their approaches, we can find ways to make better traps, break their crowbars, and sound the alarm as soon as possible. For my PhD project, I'm exploring how these Salmonella tools, or more correctly their effector proteins, are used to make changes to the host cell they've invaded. These proteins are introduced through a type 3 secretion system, which passes the effector proteins out of the bacteria and into the host cell, like they're being injected in through a needle. Once in the cell, some of these effector proteins can interact with programmed cell death pathways, such as apoptosis or necroptosis, and turn parts of these pathways on or off. We think that by using these effector proteins to activate our cell death pathways, they're giving themselves a faster escape route, like the bad guys breaking down the door and setting fires on their way out of the house. It's also possible that these pathways are a defense mechanism intentionally activated by the host cell in the hope that other cells might see these inflammatory fires and act quickly against the escaping bacteria before they can get away. My project aims to determine which of these options is more accurate, to identify the specific effector proteins involved, and to see if we can exploit this interaction for future therapeutics. By improving our understanding of the tools used by Salmonella, and by studying our existing traps to see if they can be improved, we hope to catch these invaders before they can spread into other cells, and keep Kevin's neighborhood safe until his family comes home.